Segmentation. Do programmers think that memory is a linear array of bytes? Most would say no. You could say that the programmer thinks of memory as a collection of variable sized segments, like what you see in the figure. When you are talking about a program, think of the various parts or segments of the program: the main memory, the functions, the various data structures like arrays, stacks, variables, etc. Each of these elements or segments is given a name. Here, instead of name, we will give the segment a number. Segmentation is a memory management scheme that supports the programmer's view of memory. A logical address space of a program is a collection of segments. What is a logical address? And what is a physical address? An address generated by the CPU is called the logical address or virtual address, whereas the actual address seen by the memory is called the physical address. The set of all logical addresses form a logical address space, and the set of all physical addresses form the physical address space. The function of the memory management unit is to map the logical address to the physical address. When we talk about segmentation, the logical address consists of two parts: the segment number and the offset. It is a two-dimensional address, but the physical address is one-dimensional. So here, the memory management unit maps a two-dimensional logical address to a one-dimensional physical address. And this mapping is done with the help of a segment table. Each entry in the segment table has two values: a segment base and a segment limit. The base contains the starting physical address of where the segment resides in memory, and the limit specifies the length of the segment. So how does the mapping take place? As I just mentioned, the logical address has two parts: the segment number S and the offset D. The value of the offset is from 0 to segment limit. The segment number is used as an index to the segment table. So as seen here in this figure, we use the segment number to find the appropriate entry in the segment table. Next, we compare the offset D with the limit. If offset is less than limit, then the base is added to the offset to get the physical address. Let us consider the following example from Galvin textbook. Here in this example, we see that there are 5 segments numbered 0 to 4. The segment table has a separate entry for each segment, giving the beginning address or the base address and the limit, which is the length of that segment. Let's consider the logical address 2, 53. We use 2 as the index to the segment table. We find that segment 2 is 400 bytes long and starts at location 4300. We check if the offset, that is 53, is less than the limit. If it is, then the base is added to the offset to get the physical address. That is, the base 4300 is added to offset 53 to get the physical address 4353. If the offset is not less than the limit, then an error is returned. Let us take another example where the logical address is 3, 852. Here, again, we compare the offset with the limit. The offset is 852 and the limit for segment number 3 is 1100. As 852 is less than 1100, to find the physical address, we add the base to the offset. That is, in this case, 3200 plus offset 852 to get physical address 4052. Thank you.